curve tracing. Okay. Okay. So what we did earlier, let us recall quickly. So you are having any curve equation and we need to trace the curve. So the first thing that we need to check about the symmetry, we need to check their symmetry about x-axis or symmetry about y-axis or the symmetry about both the x. Okay. And even symmetry about the line y equal to x also. So if the curve is symmetric about x-axis, then what do you see in the equation? You can see in the equation even powers of y, or you can say if you replace y by minus y, the curve is the equation will remain unchanged. Then symmetry about y-axis, x by minus x. Replace x by minus x in the equation. If the equation remains unchanged, curve is symmetric about x-axis. Sorry, y-axis. Same way, if both x and y replaced by say minus x minus y, if the equation remains unchanged, symmetry about both the axes. And same way, symmetry about the line y equal to x. So then if we replace x by y, okay, x ne jagah y kari do, and if the equation remain unchanged, then the curve is symmetric about the line y equal to x. So these are the some examples also we have seen. Then next part we need to check about the origin. That means whether the curve passes through the origin or not. So if there is no constant term in the equation, or if the equation satisfy with the 0, 0, the curve passes through the origin. We have discussed, just we are recalling. Then we need to find out the tangents at the origin if the curve passes through the origin. What is the procedure? The procedure is lowest degree term in the equation. You have to make it equal to 0. Then you will get the tangent at the origins. It may be only one also, or it may be, there may be two tangents. Okay. So if there are two tangents, then we are having the different possibilities. That is, if both the tangents are real and distinct. If both the tangents are same, that means coincident. And if the tangents are imaginary, then we can say that isolated point. If it is real and coincident, we call the origin is a cusp, and the shape is as discussed like this. If the real and distinct like this, then the shape may be like this. Okay, or any other type of shape is also there, but the tangents are these two, real and distinct. So we have also given these examples where you find the tangent, different types of tangents. The next part we have discussed was intercept. Means we need to find where the curve intersect x-axis. Just you have to put y to be 0. You will get the point where the curve passes through the x-axis. Same way about the y-axis by putting x equal to 0. That is called y-intercept. So up to now, this we have seen. The next two parts we have to see, and then we are in a position to solve the examples. The next part is asymptote. Now the asymptote meaning what? So asymptote meaning tangent at the origin. Sorry, at the infinity. Tangent at infinity. Like say this is the curve. This type of curve is there, y equal to 1 upon x. So you can extend this curve. You can say that slowly it goes towards infinity, then the distance between these two will reduces. Okay, so as this goes on like this distance gets reduces, and at the infinity it touch the axis. That means this x-axis is a tangent. Sorry, is an asymptote. So there are two types of asymptote we need to discuss if it is there. One is asymptote parallel to x-axis. You can say horizontal asymptote. This is the simplest procedure. You have to remember coefficient of highest degree term of x, make it equal to 0. I repeat, coefficient of highest degree term of x equal to 0. That is the tangent at infinity. You can call it is asymptote. Basically, it's a line. Now suppose this is the curve y equal to 1 upon x. This is the curve. So its equation is like xy equal to 1. Suppose if I want this kind of things. Now if I want to find out horizontal asymptote, coefficient of highest degree term of x. Now highest degree term is only one here, this xy. What is the coefficient of x? Y. Okay, so y equal to 0. That means x-axis is the horizontal asymptote. Same way, find out vertical asymptote. Same way, vertical asymptote. And for vertical asymptote, coefficient of highest degree term of y should be equal to 0. Coefficient of highest degree term of y equal to 0. So same example. You can see that coefficient of highest degree term of y. That means x. X is the coefficient. Make x equal to 0. That means y axis. See, this y axis is also tangent for this. Y equal to 1. Because this also extend and you can see that it touches the line at infinity. Okay, like this. Okay. So this is the things about the asymptote. Okay, everyone. Hello.
Yes, sir.
Yes,
Okay.
sir.
So two types of asymptote we need to discuss, and this is the simple method. Now next part and last part, that is nothing but region. We have to find out region. Find out part of the plane where curve does not exist. એટલે કે આપણે એવો ટાઈપનો પાર્ટ ફાઇન્ડ કરવો છે જ્યાં કર્વ એક્ઝિસ્ટ નથી થતો. Normally as intercept, asymptote, those kind of things we need to check. Beyond that, the part of the curve does not exist. Let us just simple discuss here. Say you know y square equal to 4ax and a is positive. So then you know the curve is like this. Okay, y square equal to 4ax. Now see, this is the part where curve does not exist. This is the part where curve does not exist. So that kind of things we need to find out in the region, and it is easy. See, if I take x to be negative, if I take x to be negative, then y square is negative, and therefore y is not possible. Real y is not possible. That means wherever x is negative, no part of curve exists. So these are the part. This is the part where x is negative, and no curve exists. Understand, everyone?
Yes, sir.
Yeah. So in the region, we need to find out the part of the plane, where the curve does not exist. And that finishes the discussion about the points to be discussed while we solve the example. We take one example first. Okay, let us see slowly how we can write. Okay, this kind of example will ask for 5 to 6 marks, and it will be like this. Trace the curve. So this example, let us take. Trace the curve y square into 2a minus x equal to x cube. કંઈ પણ આપેલું ના હોય એટલે સમજવાનું કે a is positive. Okay, so y square into 2a minus x equal to x cube. Okay, fine. Let us discuss first the symmetries. Now see, y even power of y. So you can write the curve is symmetric about x-axis. Give the reason. Because on replacing y by minus y in 1, that means in this equation, it remains unchanged. You can also write because there is even power of y in the equation. That also enough. And there is no other symmetry. Okay, only the curve is symmetric about x-axis. Agree, everyone? You may write down. You may write down. તમે આ એક્ઝામ્પલ લખી શકો છો. Okay. Done?
So.
Okay. Fine. So then, so this is first symmetry we have discussed. Next part we need to discuss about the origin. Now see this equation. Whether the curve passes to the origin or no. Hello. Does
Yes,
the curve satisfies the point 0, 0, or is there any constant term in the equation? Okay, that you need
no
to check.
constant.
No constant term. So the curve passes through the origin because equation satisfied by 0, 0, or there is no constant term. Okay. So next, if the curve passes to the origin, what we need to check? We need to check tangent. Okay. Now what is the tangent? Lowest degree term equal to 0. Lowest degree term. Now see what is the lowest degree term. This is the equation. Y square into 2a minus x equal to x cube. So 2ay square, then minus xy square and equal to x cube. This is 3 degree term. This is also 3 degree term because 2 degree of y and 1 of x. So total 3 degree. What about this? 2 degree term because 2a is constant, y square. So 2 degree term. Okay.
Yes.
Okay. So lowest degree term equal to 0. So 2a y square equal. That means y square 0. That means y 0, y 0. That means tangents, two tangents are there, real and coincident. And this is x-axis is the tangent. Understand?
Yes, sir.
Okay. So tangents are real and coincident. Therefore, origin is a cusp. Now, then next part is intercept. Again, we write this equation because it's in the earlier slide. So for x-intercept, you have to put y to be 0. So if you put y 0, you will get x 0, x cube 0, and so x 0. For y-intercept, you put x equal to 0. If you put that x equal to 0, you will get y also equal to 0. So there is no intercept other than the origin. That means the curve passes through origin only. Understand? લખવાનું છે. લખવાનું છે. આગળ લખાઈ ગયું છે origin અને tangent at origin.
લખાઈ ગયું એક જ મિનિટ સર.
Yes, sir.
Yeah, you have to write down. Okay, not only here but even in the exam also. Tomorrow we don't have holiday. Okay, so tomorrow also we'll have to take the class.
Yes, sir.
Okay, means there is a holiday, but I will be conducting class from home. We don't have holiday. Okay. Okay, fine. So curve passes to the origin only. Understand? Now next part is asymptote. Basically, asymptote is a tangent, and any tangent is a line. So let us find asymptote parallel to x-axis. Again, what is the thing? Coefficient of highest degree term of x should be made equal to 0. Now see, this is the equation. What is the highest degree term in x?
Cube. X cube.
3.
X cube, not 3. Term, not saying degree. આપણે word term વાપરીએ છીએ. એટલે તમારે coefficient highest degree term in x is x cube. X cube is the highest degree term. What is the coefficient of x cube? 1. That means 1 equal to 0, which is not possible. That means there is no horizontal asymptote. There is no horizontal asymptote. Okay. Fine. Now for vertical asymptote. Again, highest degree term in y. See, this is the equation. What is the highest degree term in y? Y square into 2a minus x.
X.
So y square into 2a minus x is the highest degree term in y. And its coefficient we need to make it 0. So its coefficient is 2a minus x. Its coefficient is 2a minus x. So coefficient of highest degree term of y equal to 0, 2a minus x 0. That means x equal to 2a. It's a line. X equal to 2a line is the vertical asymptote. Everyone okay? Write down. Done?
So just a second.
Yeah, okay, no problem.
Done, sir.
Okay. Fine. So we found the asymptote also. Now, two things you need to do parallelly. One is region and another is tracing of curve. Now see, we have started tracing of curve. So we write here x-axis, then y-axis here, and just this thing suggests that the curve is symmetric about x-axis. Then curve passes to the origin. Origin is a cusp also. Then draw the line x equal to 2a is our asymptote, vertical asymptote. Okay. So this is 2a. Now this is the equation y square equal to 2a minus x equal to x cube. So we write y square equal to x cube upon 2a minus. Now see, where we need to check the region. We need to check the region. एक तो અહીંયા, one is here. Asymptote is x equal to 2a. So x beyond 2a. So if our x is greater than 2a, x is greater than 2a. Now see, if x is greater than 2a, that means x minus 2a is positive. What about 2a minus x? Negative. X is greater than 2a, that means x itself is positive. So x cube is also positive. So see here, this is positive and this is negative. That means total y square is negative. That means no part of core exists when x is greater than 2a. So when x is greater than 2a, then core does not exist. Same way, we need to check one more here. This is origin and we are having nothing. So let us check here when x is less than 0. Now when x is less than 0, x cube is negative. See here, when x is less than 0, what about minus x? What about minus x?
Greater
When
than
x
0.
is less than greater than 0. So now can you write 2a plus minus x is also greater than 0?
Yes.
That means 2a minus x positive. So now y square ma x cube upon 2a minus x. This is negative and this part is positive. So total is negative. That means no part of core exists when x is less than 0. So when x is less than 0, no part of core exists. When x is greater than 2a, no part of core exists. That means core exists only in between these two. Understand?
Sir, one more time, please.
No part of core exists beyond 2a. X greater than 2a, there is no core. This is 2a. So right of 2a, there is no core. Here there is no core. And x less than 0, there is no core. So the core exists only in between these. Okay?
Yes, sir.
Yeah. So now see, this is a cost. Origin is a cost. So cost there is, then this kind of core is there. And symmetry about x axis. So and this is tangent at infinity. That means asymptote. So the core goes like this on one side. Because it is symmetry about x axis, another side also it goes like this. So this is the core that you are having like this. And this is x equal to 2a line. Understood? And here you will get full 5 or 6 marks, whatever it is. You may write down this reason.
Sir,
Hmm.
સર આપણે જે આમાં ફિફ્થમાં જે સેકન્ડમાં -x ગ્રેટર ધેન 0 કેવી રીતે આવે?
x less than 0.
યસ સર.
So what about minus x?
તો સર -x 0 કરતા મોટો કેવી રીતે થશે? હું એમ પૂછું છું.
હું એ જ પૂછું છું, હું એ જ કહું છું તને કે x less than 0 હોય તો minus x greater than 0. Take any x less than 0. ચાલો
હા હા
કોઈ x લો કે જે less
ઓકે
than
સર.
0.
હા એટલે x એટલે માઇનસ માઇનસ પ્લસ થઈ જશે. ઓકે સર.
હા બરાબર છે. ગુડ.
યસ સર.
ઓકે. Okay, everyone?
Yes, sir.
Okay, I
Yes,
want to
sir.
take one
Yes.
more example. Yeah, one more example. Let us see. Done? Written completely?
Yes, sir.
Okay. So this is the tracing of curve. This is one example. Let us take another example. Trace the curve xy square equal to 4a square into a minus x. Okay. So let us first discuss about the symmetry. So see here y square is there. So the curve is symmetry about x-axis because equation has even powers of y. Yes or no?
Yes.
So write down that symmetry. You will get one mark of one point, so that you will get 5-6 marks question. Symmetry નું આટલું લખો એટલે 1 mark. Okay. Next, let us check the origin. Now, does the curve passes the origin?
No.
No, because you can see that there is a 4a square into a.
Constant term.
That means 4a cube. So that means there is a constant term. So the curve does not pass to the origin because there is a constant term in the equation. Lucky card. Done?
Yes, sir.
Yes.
Okay. Okay. Now next let us check intercept. So x intercept. Put y equal to 0. So here you put y equal to 0, then left side you are having 0, right side you are having 4a square into a minus x. So that means a minus x here. And that means x equal to a.
Okay.
That means curve intersect x axis at the point a comma 0. Okay, everyone?
Yes, sir.
Then you need to check y intercept. For y intercept, you need to put x equal to 0. So put x equal to 0 in this equation. So x 0 here, x also 0 here. You will get nothing. Okay, that means no y intercept. A never be 0. A is always positive. A, if it is written or not written. If it is written, fine. If it is not written, it is always positive. Cannot be 0. So no y intercept. Hello?
Yes, sir.
Okay, sir.
So write down about the intercept. So it's like this, 1 mark here, 1 mark here, 1 mark here, kind of things. Okay.
Done, sir.
Okay. Next, now what? See, there is a point here, A0. So we need to check tangent at the point A0. Because there is a intercept. So we need to check tangent at intercept point also. So tangent at A0 we need to check. Now what we are doing? Suppose A0 is here. So we are shifting our origin here at this point. આ પોઈન્ટે આપણું origin ને shift કરી દઈએ છીએ. This origin is shifted to this point. Okay. So that is known as shifting origin at A0. This is a formula. If you shift origin at HK, then if small x is the old coordinate, big X is the new coordinate, then x small x equal to x plus h, y equal to y plus k. This is the formula. When you shift the origin, the old coordinate becomes like this. Okay, it's very simple. Suppose you are having original axis, x axis, y axis is like this, and new x axis and y axis is supposed like this. So this is x dash and this is y dash. So this is our new origin. So if any point xy about this origin becomes say capital X, capital Y about this origin. So what is the relation between this xy and xy? Okay, that is the thing. This is the relation. 12th standard માં આવે છે. So shifting the origin at A0. A0 is our HK. X equal to x plus h. So x equal to x plus a. Y equal to y plus k. Y equal to y plus 0. આ 0 છે. અને આ a છે HK. Because now our origin is shifted here. આ આપણું origin થઈ ગયું. અગાઉ આ origin. So original origin 0 0 માં આ equation છે. આપેલું છે. પણ આ x dash y dash new origin માં આ equation કેવું બનશે? That we need to check. So what is x? Small x is big X plus a and small y is big Y. So x ની જગ્યાએ x plus a લખો, y ની જગ્યાએ y. a minus x ની જગ્યાએ minus x આવશે કારણ કે a minus x is આ x આમ જશે. હવે આ જે કર્વ બને આ કર્વ એનું ઓરિજિન કયો થશે? A0 થશે. આ બંને ઇક્વેશન સરખા જ છે પણ આનું ઓરિજિન 0 0 છે, આનું ઓરિજિન A0. I want to check tangent at the origin, but now our origin is A0. I want to check tangent at A0. Same formula, lowest degree term equal to 0. તો આમાં lowest degree term કઈ મળશે? જો xy square છે 3 degree term થશે. ay square is 2 degree term. અને 4a square minus x છે એ 1 degree term. So what is the lowest degree term? 4a square minus x equal to 0. That means x equal to 0. But what is big X? Big X is small x minus a is equal to 0. That means line x equal to a is the tangent at the point A. Understand? So
Yes,
this
sir.
is tangent at A0. You need to write down properly. આ line tangent at A0 થશે. કઈ line? X equal to a line. એનો use કરીશું આપણે when we trace the curve. So write down this part. Write down.
Done, sir.
Completely. Okay. Fine. Good. Now, next part is asymptote. Okay, now we are looking about the asymptote. Okay, what is it? First asymptote is asymptote parallel to x-axis. Asymptote parallel to x-axis. So let us have asymptote parallel to x-axis. What is the thing? Highest degree term of x we need to find out, and its coefficient we need to make it to be equal to 0. Now see, what is the highest degree term of x in this equation? Highest degree term of x in this equation?
xy square.
Xy square. Does 4a square minus x is also not having x?
Yes, sir. 4a square x2.
That is also there. Okay, both. So that means coefficient of highest degree term is what? This is y square, and if I take here on this side, it will be plus 4a square. Agree or no?
Yes,
sir.
sir.
Yes.
But this is not real. That means no horizontal asymptote. Understand?
Yes, sir.
Same way, let us find out parallel to y-axis. So this is the equation. Where is that? Here. So what is the highest degree term of y?
X.
I repeat. What is the highest degree term in y?
1.
I repeat.
So xy square. Sir, xy square.
xy square. xy square. Term. I have said term. આખું જે પદ હોય એ. What is the highest degree term in y? Is xy square. Now, what is the coefficient of that highest degree term of y?
X.
That is nothing but x. So x is the coefficient. So make x equal to 0. That means y-axis. So y-axis is the vertical asymptote. Okay, everyone?
Yes, sir.
Lucky card asymptote. Now you write down about s. Okay. Next. Done?
Yes,
Done,
sir.
sir.
Yes. Yes, sir.
Okay. Now we can check parallelly region as well as things. Let us see. The curve is symmetric about x-axis, first of all. So that we did. Then it does not pass through the origin, but it passes through the point x-intercept is A0. And at the point A0, what is the tangent line we found? Tangent line is x equal to A. So x equal to A line is the tangent line. So this is x equal to A line. This is the tangent line. What about asymptote? No horizontal asymptote, and y-axis is the asymptote. So this is asymptote. Y-axis is the asymptote. Write down here. Y-axis is the asymptote. Okay. This is the equation. xy square equal to 4a square a minus x. So we write y square equal to 4a square a minus x upon x. Now we need to check the region also. So here we need to check when x greater than a, and here we need to check when x less than g. So if x less than 0, so x is negative. What about minus x? Positive. Suppose x is minus 2, then minus 2 is positive, like this. Can I write a minus x as a plus minus x? So this part is positive, this part is also positive. Sum of two positive number is positive. So a minus x is positive. So a minus x positive and x is negative. So y square is negative. That means no part of curve exists when x is less than 0. X less than 0, no part of. Let us check x greater than a. Our side. So when x is greater than a, okay, x greater than a, that means x itself is positive. X પોતે positive. X greater than a. Suppose a 2 છે, તો આ રીતે આગળ જશે. X is positive. What about x minus a? That is also positive. X greater than a, ના આમ લઈ જાઓ, એટલે x minus a positive. Sign change કરું. A minus x negative. So now this is a minus x negative and x is positive. So negative upon positive, so negative. So y square negative. So no part of curve exists when x is greater than. So x less than 0, no part. X greater than a, no part. Y-axis. Asymptote a0 is. X equal to a line is tangent. So you can see that this is the shape of the curve. Easily you can find out. Easily. Because this is asymptote and symmetry about x-axis. That means x side find karo, which side automatic. Yes or no?
Yes.
So
Yes.
write down. Write down and draw the curve. Trace the curve properly.